say round to the nearest unit, so I don't need to leave it in simplest radical form. Multiply it all together, round it. When it says nearest unit, means whole number, no decimals. So if you multiply that all together, you should get 23 after rounding it, and millimeters squared. Okay, one last example where we will have to draw in some angles and solve for something. The side of a regular triangle is 16 feet. What is the area of the triangle? Okay, so all I'm told is one side is 16 feet. Find the area. The area again, 1/2 the perimeter times the apothem. We can find the perimeter. One side is 16. I have 3 sides. So the perimeter is 16 times 3. To find my apothem, we're going to do something similar to what we did up here with our regular hexagon. The apothem goes from the center here of my regular triangle, perpendicular to a side. To find that, let's draw in the radii. So from the center to each of my vertices. These angles in the middle here, once again, form a whole circle. So if I add them together, they add up to 360. In this case, only 3 angles, because it's a triangle, just 3 sides. 360 divided evenly by 3 gives me 120. So any of these angles here are 120 degrees. When I drew that apothem in, that bisected my 120 degrees, making this angle in my right triangle 60 degrees, and creating once again my special right triangle of 30, 60, 90. The one other piece I forgot to leave off, when we drew this apothem, because it's an isosceles triangle, it bisects this side. So if the whole side's 16, it breaks it up into 2 segments of 8 and 8. So now I've got a special right triangle. I'm trying to find this side, the apothem. Let me redraw my special right triangle off to the side here. There's the right angle. Here's my 60 degree angle. There's my 30 degree angle. This side I know is 8. And this side is my apothem. This is the side I want to find. So in this case, across from the 30 degree side is x. Across from 60 is x times the square root of 3. And across from my right angle, the hypotenuse is 2x. So the side I know in this case, 8, is the x times the square root of 3 side. 8 is equal to x times the square root of 3. We use this side to solve for x. Solving for x would just look like dividing each side by the square root of 3. X is 8 over the square root of 3. Normally we don't like leaving that radical in the bottom of our fraction, and we would simplify it. If it asked me to leave my answer in simplest radical form, I would definitely want to do that. Since it just says round to the nearest unit, I'm not concerned about that, because we're just going to divide this and calculate it and round it off. So x is 8 over the square root of 3. That is this side. This side is just x. X is 8 over the square root of 3. That's the length of my apothem. 8 over the square root of 3. So plug that into our formula for the area. Now we have all the pieces we need. We just need to multiply all of this out. If I were doing it on my calculator, I would start with 8 divided by square root of 3. Then I would say times 3 times 16 times 1/2. And we're rounding it to the nearest unit. If it says nearest unit, just like up here, that means whole number, no decimals. If you do that and round it off, should be 111 feet squared. That's our last example for this section, finding the area of regular polygons. So like our first two examples, sometimes it's nice. You know the perimeter, you know the apothem, and you can just plug it into our formula. Sometimes in the examples down here, if all you're given is a side, you need to draw in some radii, find the measure of these angles, use your special right triangles to find the length of the apothem. So I'm going to follow this video up with another, doing a couple examples from the homework that may be helpful for you to see a couple more examples. But that's all for this unit.